let's see, you are, if my sources are correct, you're building web apps with Blazor, which is very cool. And you have been a software developer since 1995, focusing mostly on Microsoft technologies, sounds similar to my background, having achieved multiple certifications from Microsoft, MCSA, MCAD, MCTS, and MCT. You develop, teach, and tour the country to present various topics in .NET. You're involved with the Cleveland C#VB.NET user group, where you have been the group leader since 2003. And in addition, you are the leader of the .NET study group and an author for the Visual Studio Magazine and an MVP since 2013. Wow, congratulations, that's a long time, long-running MVP. When not coding, you love spending time with your family and friends and volunteering for his local church. So without further ado, Sam, yay!
Thank you, Lee. All right, let me go ahead and share my screen.
I'm looking for it.
Yeah, I'm requesting control.
Are you? That's a new trick. You should just have a share button.
A share
Maybe
button. Share desktop. And
oh yeah, and it's going to say, hey, do you want to overwrite this other person who I was showing the, just go ahead and overwrite their screen, or I can figure out how to stop sharing, stop presenting. You got it, you got it.
Okay, so now you should be able to see my splash slide.
Yes, sir. And all right, and it's live. We got you on the right, we got your screens on the left.
All right, very good. Well, good afternoon, everyone. My name is Sam Nasr, as Lee had mentioned, and we're going to be presenting on building web apps with Blazor. So just wanted to give a shameless shout out to the local Cleveland C#VB.NET user group that I've been running since 2003. Now that we're meeting virtually, we're technically available to everybody. Meetings are free of charge and open to the public. We meet typically every fourth Thursday from 6:30 to 8:30 Eastern Standard Time. Meetings are recorded and posted on my YouTube channel, and we cover a variety of topics related to .NET. So that includes Azure, SQL Server, Blazor, of course, and anything that touches .NET. You can find all the meeting information on meetup.com, Cleveland CVB.NET user group. I know it doesn't roll off the tongue very easily, but if you search for Cleveland C# and meetup.com, we should be the first entry that comes up. The introduction, as Lee had mentioned, so I'm gonna just fly through that. Now, jumping right into it, with modern web applications, typically when we build a web app, it's composed of a combination of these three languages, HTML, CSS, and JavaScript. So it's a various combination. When we evolve to ASP.NET and MVC, essentially we have now some front end that is, again, composed of these three components. Now enters Blazor. But before we talk about Blazor, we have to discuss what WebAssembly is, because Blazor relies on WebAssembly. So the question is, what is WebAssembly? WebAssembly is a low-level assembly-like language that basically compiles into a binary format, and it runs in the browser. So we no longer need to produce HTML, JavaScript, and CSS, but rather we can produce binary-level code, send it down to the browser, and then the browser will compile it and execute it there. So it provides near-native performance because it is executed by the browser. And I say near-native because it is byte-level code, just like assembly languages. So assembly language, essentially it's byte-level code that is then compiled into machine executable code and then run on the machine. Because we're running in the web, we have no idea what type of web browser or what platform the client or the user is using. And so that's why it compiles down to this byte level code that then gets further compiled down to the machine level by the browser and executed in the browser. So it provides third generation languages such as C, C++, and C# with a compilation target. So right now you can target Linux, you can target Windows, but now thanks to the Mono project, we're able to utilize that and be able to compile things down to a WebAssembly target. And it is designed to run alongside JavaScript. It is not necessarily the JavaScript killer, but it is more of an alternative to using JavaScript. We can now use Visual Studio and a language that we all know and love, C#, and be able to write code in that instead of having to bounce back and forth between C# and JavaScript and HTML. So WebAssembly JavaScript APIs are loaded into the browser, and they load the WebAssembly modules into a JavaScript app, and we'll run through that in just a little bit. So with WASM, or WebAssembly, this was introduced back in 2015, and then in 2017, that's when all the 4 major browsers started supporting it. And at that point, Steve Sanderson from Microsoft basically thought of an idea. Well, if we now have code that compiles in the browser and it's a target, then why don't we utilize the Mono project and be able to take .NET code, compile down to that target, and then let the browser take it from there. And so from that point on, Blazor basically became the brainchild of Steve, and then it manifested itself into a production level product that is now included within the .NET Core framework. To find out which browsers support WebAssembly, best thing to do is to go to caniuse.com, and this is an updated slide that shows the variety of different browsers and their support of WASM. So now that we have WebAssembly as available to us, and we know that we can compile code in the browser as long as we send the right targeted compiled code to the browser, what is Blazor? Where does Blazor come into this? Blazor essentially is a web UI framework, and it's based on C#, Razor, and HTML. It's used to build composable web UI components. So now I can create a component in Blazor and be able to use that in a variety of different places in my code. Where we get the name Blazor, essentially it's browser plus Razor. And if you say it fast enough, you'll see that there's an L that gets blended in there. And so that's how you end up with Blazor. So it runs .NET assemblies in the browser via WebAssembly-based .NET runtime. So we take our code, we build it in C# within the Visual Studio environment, and we're in the .NET Core framework. And once we compile it, basically creates a .NET assembly that is now being able to execute in the browser. And like I mentioned before, it's built on the Xamarin's team plans to bring Mono to the web using WebAssembly. So what Blazor is not. Blazor is not a way of deploying UWP or Xamarin apps in the browser. It is a new framework. It is a target compilation. It is not a plugin that we just download Blazor and plug it into our browser like with other plugins in the past, but rather it is a framework that's used for development. It is not a rebirth of Silverlight, and as much as I loved Silverlight and hated to see it go, this is not a rebirth of that. And it is not a new version of the defunct script sharp, which was previously brought but then kind of faded away. And it is not a transpiler, meaning we don't take .NET code and then compile it into JavaScript and into JavaScript and CSS, but rather it's compiled into a different target altogether. And it is not to be mistaken for Blazor with an ER. And the reason I mention this is as you're coding and you're searching for things on the web, please be sure not to mistype it with the ER ending, because ER, Blazor, is the web browser for the Palm handhelds, which went alongside in the 90s, but nonetheless wanted to make sure you don't fall into that pitfall. So with Blazor, what ends up happening is that we have the code, we compile it, and then it interacts with the DOM component of the web page. So we have Razor components along with the .NET and the WebAssembly, and it's all running in the browser, and then it interacts with the DOM. And we'll see how that happens as we step through the demo. So the advantage of Blazor is now I can just focus on the development environment that I have grown comfortable with, C# and Visual Studio, and in the .NET and .NET Core framework. I no longer have to worry about all these different JavaScript frameworks that keep spawning left and right. Node.js, Backbone, Sencha, Aurelia, Ember, so on and so forth. Now, this doesn't mean that I have to replace all that framework in my code, but rather if I did not learn these frameworks up till now, I really shouldn't bother, because now we have a new method of addressing client-side development. I should also mention that obviously JavaScript has been around for approximately 20 years or so. I think 25 actually. So there's a lot of code that's out there, billions upon billions of lines of JavaScript code. That is not to say that investment is going to waste, but rather with Blazor, we can interact with .NET code, and then we can call into it. And likewise, from JavaScript code, we can call into our .NET code that's running in the browser. I want to pause for just a second and see if there's any questions. Lee, do they have the option to jump in verbally, or is it all through the chat window?
It is all going to be through the Discord or the chat window, and I'm not seeing any questions just yet.
Okay.
But yep. I do keep checking. I'll let you know if there are any.
Okay, very good. So onwards and upwards. All right, so to run Blazor, essentially system requirements, I need the latest version of Visual Studio, and it will work with Community Edition or higher. And once I have the latest edition of VS 2019, that also means that I will have .NET Standard, as well as .NET Core and C# installed. Oh, let's step through a demo. And what I will do is I will launch a new instance of Visual Studio. So I have some pre-made demos, but I'm going to start this one from scratch. So again, you can do that on your end as well. And we'll go ahead and create a new project. And while that's humming, I'll take some water. So to expedite things, I can just simply search for Blazor. And there it comes up with the Blazor app. Notice that there's just one template available to me here. However, once I select next, and we'll call this Blazor app Nova create. Okay, so we started with one template that I had the option to choose. Now it's giving me a couple options. I can choose the Blazor WebAssembly application or the server application. I'm going to go ahead and click the WebAssembly app, and then if you notice, I have two additional options: ASP.NET Core hosted and progressive web applications. And these are only available with the Blazor WebAssembly app. When I click on the server app, you see those options are not available. So just to keep things simple, being that this is the first demo, I'm just going to choose Blazor WebAssembly app, and I'm going to leave these two options blank. We'll go ahead and click Create.
So tell me, Sam, what is the difference between this and Silverlight? What's the biggest difference between those two? Seems like there's some similarities.
There are some similarities. So Silverlight required a plugin where I basically had the .NET code, and it was a miniaturized framework that I had to install on my client side, and it was done for the first time every time a client had to use it. Let me rephrase that. Every time a client went to use a Silverlight application, they had to download that framework once and only once, but then that framework was required to be on the client's machine. In this case, I'm not downloading anything, and there are no plugins. It is simply a compiled code that runs within the browser. So as long as the browser supports the WASM or the WebAssembly capability, I should be able to run my Blazor code in that browser. Does that make sense?
Sure does. Yeah. Is there a security difference? Can you do more stuff
absolutely.
than one or the other?
So we'll touch on that in just a little bit. But essentially, because the code is running in the browser, there are the restrictions that take place that won't allow me to access the file system and anything local to the user, just like today. So like I said, that's going to be in an upcoming slide. Any other questions? Either from Lee or anyone else on the Discord channel?
Yeah, there's a couple more. Unmuted. Yeah, there's a couple more questions.
Sure. Fire.
Don't the DLL down to the client, asks Jim.
Say that again, please.
I think he's asking if there's a DLL involved and whether that downloads to the client.
Yeah, so what happens is there's a bootstrap process where we load the JavaScript file that essentially loads the DLL into the browser. And so what happens is you're essentially executing that code in the browser, and it gets compiled down to the machine level in the browser.
And then what would you create a server-side Blazor application for?
So the server-side Blazor application, and again, we'll discuss that in upcoming slides, but basically, if you were to do everything on the Blazor client side, then that means everything is downloaded to the client. And so if I have a secret formula for calculating discounts, for example, if I have a financial site that calculates pricing, and I don't want my end user to see that or to expose that formula, then I would hide all that on the back end in the server side. If I wanted to make calls to APIs or databases, I would also do that on the server side as well.
Makes sense. That's all our questions.
Okay. And folks, feel free to jump in at any point in time. Would love to take on questions as they come. All right, so if you recall, I just created a very simplistic example, and I selected the WebAssembly, did not choose that it's web hosted, did not choose that it's a progressive web app, and this is the splash screen that comes up once the demo is created. So this is the default template from Microsoft. We'll go ahead and close the splash screen, and let's take a look at what we have as far as the pages. So the dependencies section, which I'm familiar with for all my web apps, properties, and then let's take a look at www-root. So I have a standard CSS that goes along with it, including Bootstrap and the app.css file. And then we have the index.html file. And let's go ahead and open that up. And you'll see that here we have just some basic items located in the header. And then in the body, this is really where the rubber meets the road. So in here, I have an app tag, and right now it's just preloaded with the text loading. And then there's, excuse me, some additional error messages here if I was to encounter an error. And then we see that it references the blazor.webassembly.js. So this file, this is what gets loaded in the browser and kind of gets things situated and started. So in other sections of the app, I have several Razor pages located under the Pages folder. I have a counter.razor, fetch data razor, and index razor. So this example is created by default by just selecting the Blazor app. Let's go ahead and run it and see what kind of results we get. So I hit the play button. It is now compiling and should be launching a browser in just a second. And as it builds and loads up the browser, you should see the loading message coming up. There it is. And now it's going to go away and actually load the first page. And there is my hello world. And if you recall, there were 3 pages. I have a counter, fetch data, and then an index razor. So my index razor is just simply the hello world message. There it is in the header, and it just has a title. Looking at the other pages, I have a counter. So here, it's got a click me button, and when I click it, you'll see that it's just an incremental counter that goes up by 1. And you'll also see that the page is not flashing. It is not reloading every time. Everything is running inside the browser. When I go to my Fetch Data tab, essentially what it's doing, it's downloading some fictitious test data for weather, and it's downloading it from a file under the sample data in weather.json. So the basic anatomy of the Blazor application is under www root, I have my CSS, I have my sample data that I'll be stepping through in just a second. It's just a JSON file. The icon for the application, the index.html, which has the reference to the Blazor WebAssembly.js, as well as the application tag or the app tag. And then in my pages folder, I have the 3 pages that we just stepped through: counter, fetch data, and the index razor. And then I also have some shared components here, which are essentially for the layout. So I have the main layout of the page, I have the navigation menu, and I have the survey prompts. So looking in my program.cs, this is where things get started. And you'll notice that here it's looking for the application tag, and it's going to be replacing it with this app class that's listed here. So essentially, Blazor is a single page application. What it's doing is it's going to load the page depending on the route that's being submitted, and it's going to replace the contents of this application tag. And so in this case, whenever I click fetch data, or I look at the navigation menu or the survey prompt, basically it reloads the contents into here and leaves everything else the same. Looking at app.razor, this is what handles the routing. And so here it is looking for the current assembly, and it's using reflection to look in the current assembly to see what are the different routes that are available. So this app.razor, it intercepts incoming calls, and then it looks to see what matches the components that are within the assembly, and then it defaults to that. So once I run the application like I have here, you'll notice that when I go to counter, you'll see that the URL is counter. This matches with the page directive that is in my counter.razor. And you'll see in my razor pages, every page starts with the add page directive, and I give it a name. And in this case, /counter. If I go to fetch data.razor, same thing. I have fetch data, and with index, this is the home page. So while we're on the subject of routing, what I could do is essentially looking at the counter.razor, I can cut and paste this, and I can call it counter v2. Whatever I want, let's say counter for Sam. And let me stop and restart the application. So now it's going to build the application again, and it'll open up the browser. And while it's doing that, essentially what I'm going to do is I'm going to let it load, and then I'll click on counter, and you'll see that it's going to take me to the counter as expected. But then if I change the URL to counter v2 or counter for Sam, then it will route to that same page again, because I specified it in the page directive. So here I clicked on counter, and counter is specified in the URL. If I type in counter v2, it's going to load, and it's going to take me to the same page. If I say counter, same thing. Okay, so that's the routing and how it knows which application or which Razor page to load depending on the URL. So it makes things very simple. I'd like to pause and see if there's any questions.
There are no questions at this time.
No questions, okay.
Although, actually, I forgot to ask one earlier from Jim. He said, are you ready to do another Give camp? I don't know what that means.
Am I ready to do another GIF camp? I think he's referring to the Cleveland area, and unfortunately, I'm not the one in charge of that. But if you reach out to me, I can connect you with the folks in the area that do handle that. Okay, so we got the routing covered. We're hitting the page. So why is it that when I click the counter or click the click me button, I don't see a page reload, but rather everything is running inside the page? If we take a closer look at it, we'll see that basically this Razor page, aside from the routing up here, it's essentially an HTML page. What separates a Razor page from your basic HTML is utilizing this @ symbol. So once I utilize the @ symbol, then that means I can access .NET code and reference it. So as you see here in this paragraph element, I have current count, colon, and then I have the @ symbol. So I'm escaping to utilize the .NET variable here. Current count. Where is current count defined? It is defined in the code segment down here. So I define it as a private integer and set it to 0. And it's a global variable inside the code segment. And then when I call increment count, I do that whenever I click on the button. And there you see the button. It's utilizing some Bootstrap CSS. And then in the onClick event handler, I'm specifying the name of the .NET code that I want to run, which is increment count. And that's included in my code segment down here. And all it does is just simply increment it by 1 rather. Okay, so now what I did is I created this counter page, and essentially it is a composable UI unit that now I can use in any part of my my application. All I have to do is just reference counter as a tag. And so when I execute it, you'll see that it just does nothing but increment it. And again, there's no page flicker because this code is being executed in the browser itself. No JavaScript. I just simply created C# code in my Razor page. And because I'm in Blazor, it compiled it down to WebAssembly and then downloaded it to the browser. And if we take a look at other pages on here, let's go to fetchdata.razor. So with fetch data, again, this is another Razor page. And here we specify the routing for it, that it's going to be /fetchdata. And here I'm utilizing dependency injection, where I'm passing it in the HTTP client, and I'm going to be using that later on inside this page. I have a couple HTML tags, and then I have some code where I'm checking to see that inside my code, what I'm doing is I'm defining an array of weather forecasts and calling it forecasts. I have an asynchronous method that basically gets from the server sample-data/weather.json, which is this file located right here under sample data weather.json. And this file is nothing more than JSON data of fictitious weather information. Once I get the data, essentially I parse through it and split it out as seen here. And so here you see some Razor code that essentially goes through the entire forecasts array and then parses it out, the individual items, the date, the temperature in Celsius and Fahrenheit, and then the summary. And so the end result is this. So here, again, I'm utilizing a combination of HTML. I'm using my C# code where I can actually get data from the server, parse it through my C# code, and it's all happening inside the browser. And so these are the 3 pages, again, created by default in a basic Blazor WebAssembly application. If I go ahead and take a closer look at the properties of that, and because I'm running, it's grayed out, so let's go ahead and stop the application. There you see that it's targeting the .NET Standard 2.1. And if I go over into the folder structure, open folder in File Explorer, we'll go to bin, debug, and you'll see that basically it compiles things into DLLs, including the WebAssembly.dll, and then there's, pardon me, and then you see that there is the WASM items that are being sent to the browser or WebAssembly. And any settings that are in my JSON file as well. So what I could do is essentially take the contents of this binary folder and I can put them on GitHub pages, and it would just serve up. As long as the browser loads it, it's going to execute without a problem. So think of it as a step above static HTML. Basically, it's compiled code that runs in the browser, and instead of writing JavaScript, I wrote C# code. And so I can just load it up through GitHub pages, and it would just continue to load, or any web server for that matter. I don't necessarily need the .NET runtime installed on that server. I can just take that compiled code and run it from there. That's only for this type of template. There are other templates that we'll talk about in just a little bit. But before I move on, again, wanted to pause for any questions.
And I am not seeing any new questions. Nope,
Okay.
Nothing so far.
Am I explaining it that clear, or people kicking into lunchtime coma? What's happening?
You're crystal clear. Yeah, there's,
All right.
there's plenty of people who are here and watching, and I'm sure that they are wrapped with attention, and it's all making perfect sense.
Very good. Again, I invite you all to jump in with any questions at any point in time. So we just concluded the first basic demo. Let's jump back into our PowerPoint. And so you saw that I created everything through the Visual Studio interface. However, everything can also be done through the command line tools as well. And here's just a sample of creating the Blazor application through .NET command line tools. Now, we talked about creating a very basic model, right? And that is this Blazor WebAssembly here in the upper left-hand corner. You also saw that as I was creating the application, I had the option for the checkbox to say that I wanted it to be ASP.NET Core hosted, which would essentially create this. And basically, it would be a .NET Core application on the back end, generating the code for the front end, and then interacting that way. So it's ASP.NET Core hosted in the sense that it is not just the WebAssembly files by itself, but now it's a little bit more dynamic because I can feed it things in through the ASP.NET framework. And then the final template is this Blazor server. And what this allows me to do is essentially use Signal R, where I can make a call back to the server repeatedly on calls whenever I need to access data. So let me go ahead and close some of these, and we'll go ahead and create a server example. So pardon me for just a moment while we launch another instance of Visual Studio. And I'm going to create a new project. Search for the Blazor template. By the way, any VB.NET users in the crowd? If you are, I hate to disappoint you. Blazor is only available for C#.
Well, that's interesting.
Yeah. I just heard on a podcast that there's going to be no additional language enhancements to VB.NET, but they will continue to maintain that framework going forward. But no new additions to the language, unlike C#.
That's interesting. There are still a lot of people out there who are passionate fans of Visual Basic. You run into them at conferences and stuff.
True. I don't have anything against VB.NET. I can actually kind of ride either wave, but I've noticed that C# has a tremendous following and a tremendous demand in comparison to VB.NET. But not to digress. So now I'm going to create another application. I'm going to select my Blazor template, select next, and I'm going to call this Blazor App Nova 2. And let's put it in my demos folder. Go ahead and click create. And now when I'm being prompted, I'm going to select the Blazor server app. And once I click create, let's maximize that, close the splash page, and then let's take a look at our solution. So with this, now we have things that are running on the server as opposed to everything being downloaded from the client, meaning looking at the weather forecast.cs and the data, it is now housed within .NET code as opposed to JSON data. So I will open up Solution Explorer again. And so this is a little bit different in the sense that, again, I have my program.cs, which gets everything started. And if I look at I still have my app.razor, which is universal. It will continue to look at the assembly for the routing. Now here I have a startup file because now this is a server-side application. So I have a startup.cs that handles all global things for the application as a whole. I also have this host.cshtml, and this is the file that's used to essentially handle the templates as well as this application tag that we see here. If I look in my, let's see, imports razor. If I look in my index.razor, I see that things are essentially the same, where I have the page directive on top. Same thing with fetch data. And now, instead of injecting an HTTP service, it is now using the forecast service with this weather forecast service. And if I jump to that, go to the definition, that is located within the data folder of the server app. So everything here is intended to run on the server. And as you see, I'm no longer using JSON data, but rather all C#, and it's compiled and run on the server and then served up to the client. So the end result is essentially the same. And let me go ahead and execute that. I apologize, sometimes it takes a little longer to load with so many things running. And I have until 150, is that correctly?
Yes, sir. You have until 150.
Okay.
I've noticed sometimes when I run Blazor, by the way, that I have to hit F12 to get the debugging. If I hit F5 in Visual Studio and then I'm in here, I have to hit F12 to open the debugging tools before it will continue. I don't know if you've ever seen that.
Yeah.
Weirdness.
So essentially, if we were to do that, do F12, and then if I was to go to network and then reload the page, there I see all the items that are being downloaded to my page, of which is the blazor.server.js, which again is the JavaScript file that kind of gets things loaded and run on the browser. And the results are essentially the same: the click me counter, the fetch data. Now, if we step through the fetch data, so here, if you recall in the previous example, because it was all WebAssembly and all client-based, this one is more server-based. And so what it's doing here is it's making an async call to get forecast async. And let's see, if we jump to that, there is get forecast async. So we'll put a breakpoint here, and then let's escape that. We'll reload fetch data, and you see now I'm hitting the breakpoint because it's going back to the server to retrieve that. And all it's doing is generating a random number, and then it is going to use that for getting the temperature. And there we see it's just generating a random temperature, putting it in an array. And then once we populate this forecasts, then we can go here in our HTML and be able to execute that and basically being able to parse through it. And we'll just hit continue, and there is our weather data here. Let me pause for just a moment and see if there's any questions.
Sorry, I should have clapped. Woo, weather data.
Thank you.
There's no questions at the moment.
Okay, very good. So we have, continuing on. So we have this Blazor WebAssembly. Whoops. Blazor WebAssembly that can run in the browser as is. I just put my code together and then it will load it up in the browser, or I can host it in ASP.NET Core, or in this last example that we had just seen where I have a Blazor server and the interaction happens between the browser and the server process utilizing Signal R. So what happens is, if I was to use the server model, essentially I have the objects in the DOM, and every time I go to retrieve, like as you had seen, when I click for fetch data, it's basically going back to the server using Signal R, hitting those components, getting the data, and then sending it back to the browser. Question was brought up earlier. Now that everything is running in the browser, can I do everything in .NET in the browser? And the answer is no. Obviously, because it's a browser, there are limitations. You can code it, but when you go to execute it, if it's not supported in the browser, it's going to throw an exception, specifically platform not supported exception. And so you'll get this exception when you try to do things that you're not supposed to do in the browser, such as accessing the local file system, looking at the network connection, or opening a database connection. Since there's no questions, here are some of the frequently asked questions that I get. Is the total .NET Standard API supported? Things like TCP, UDP, sockets, etc. I kind of touched on that. So yes, the .NET Standard will be supported, but with some browser-specific limitations. And if you touch on something you're not supposed to, you'll get the platform not supported exception, as I had mentioned. Does Blazor compile my entire .NET-based application to WebAssembly? No, only the .NET runtime itself is compiled to WebAssembly, and then it's sent down to the browser. And can components be created or integrated into existing ASP.NET MVC 5 projects? So think of it this way. Basically, Blazor is not tied to any specific platform. Think of it as just another form of JavaScript, if you will. So you can attach it or not attach it to MVC or any other application. In addition, you can also interop, meaning if you have Angular code that's currently out there, you can write Blazor code so that you can call into that Angular code. Likewise, vice versa, in JavaScript or Angular, you can make calls to access the Blazor components within the application. So it's bi-directional communication there. And last call for questions.
I'm curious, Sam, how does it work when you have, if your code is not being compiled to WebAssembly, it's being sent down as a DLL, then how is that being executed? And if it's not being executed and converted into WebAssembly, does that mean it's as fast as WebAssembly, or is something else going on and it actually ends up being slower?
So if you recall, WebAssembly, it's similar to the assembly language. Whenever we compile code on a desktop application, it compiles down into an assembly language, right? And or in the .NET days, it compiles down to an assembly, I should say, right? And then that assembly is then further compiled down into the machine level code. So if I'm running .NET on a Mac, I can take that same app and run it on a Windows or a Linux box. But each time I compile that code, it's going to produce a different DLL because it's targeting that framework. So with WebAssembly, what happens is I'm compiling down to that specific browser. Let me rephrase it. I'm compiling down to WebAssembly, which then the browser takes and compiles it down to that specific machine code and executes it on the machine. Does that answer your question? I know it's a little bit abstract.
Well, I guess I thought you were saying in that previous slide that the DLLs, your code was actually not getting compiled to WebAssembly.
Not all of it, only the stuff that's running in the browser.
Only the .NET runtime itself is compiled to WebAssembly. So I was curious what everything else is then.
So things that are server side, for example, that wouldn't be compiled and sent to the browser.
Gotcha.
It's only front-end based items that are that are compiled to WebAssembly and sent. So if you recall in the browser, in the server example, where I'm hitting the server using signal R, the forecasts or the algorithm that I'm using to come up with a forecast, that's running on the server. And so there are hooks, and let me jump back to here. So there are essentially hooks in the browser, in the UI, to actually call back to the server, get whatever is needed from there, and then return it to the DOM. So I'm not compiling the code for the weather service here and sending it to the browser, but rather I'm compiling it and running it on the server, and then just having hooks to tie into the DOM when it's needed. Does that help?
Sure does.
Very good. Okay, any questions from the audience? Lee, unfortunately I can't see the Discord site, but any questions there?
There's no questions in Discord. And let's see, Jim is asking, what would you create? Nope, sorry, that was already asked. Oh, here's a couple new ones. Tandy, how does server-side determine the difference between current UI and the updated UI?
How does server-side determine the difference between current UI and updated UI?
Because it's sending diffs down, right?
I'm sorry, it's sending what?
It's sending a diff down. So if you click a button, it's just sending down the diff in the DOM. So I think Tandy is asking, how does it know what changed?
So basically, if we look at it, you're referencing the component, and then the component, like for example, so this is a component, and if we look at all the other pages, counter, for example, this is a component. So this is a UI element, and in the case of fetch data for Razor, what it's doing is it's hitting the server. And so I don't necessarily have to update the UI, but basically it knows, because it's in the UI here and it's referencing this component, it's tied to that component on the server end. So the hook essentially stays the same. If I update my UI, my hook is still the same, tying into retrieving this code and this code.
Right, and I think also probably the server side is storing a copy of the entire DOM for every single client that connects, right?
Yes, true.
When you're in server-side mode. Jim asks, is Blazor ready for production level applications?
Absolutely.
All right. Parda asks, is Blazor going to kill all the scripting languages?
That's a question that always comes up. I wouldn't say it's going to kill it. I mean, that's been said many times in various degrees regarding Angular, regarding TypeScript. So I think JavaScript is here to stay. Not to mention there's a 25-year history behind it and various implementations of JS. So it's not necessarily going to kill it, but it's certainly another viable option, because now I don't have to learn two languages. I just have to learn the one. And quite honestly, for those that know JavaScript and C#, the syntax really isn't that different. I mean, obviously you can do a lot more in C#, and C# is a compiled language and strongly typed versus JavaScript. But if you know one, you can adapt very quickly to the other. So I wouldn't call it a JavaScript killer, even though some people do. I just look at it as another option for creating UI interactions.
Stan asks, how do we determine when we should do Blazor client or when we should do Blazor server in general if we need to create a new Blazor web application?
So depending on what you're trying to safeguard and protect from your front end, if you have a secret proprietary formula that you don't want to reveal and you don't want to download it to the client, then you would do that on the server end. And then the hooks would be tied in from the UI to the server, and you would get the data that's needed there. Think of it no different than JavaScript. If I had a formula for calculating discounts for specific customers, I wouldn't necessarily put that in my JavaScript file and have that exposed on the client. I would put that on the server backend and just call into it to get the data that's needed. And if I need to do any API calls, if I need to open up database connections, that would have to be done on the server end, as opposed to not being allowed to do it on the front end or the UI.
Right. So probably if you're doing client side, it's a little bit more of a complex UI, because to get to the database, you have to make a web connection or a SignalR connection back to the server and have it do the entity framework, right? So you're having to do sort of more work. Tandy asks, does the server side keep a copy of the DOM tree like React has a virtual, and Angular 2 actually has a virtual DOM?
So yes, to a degree. So it is maintained on there, and we touched on this just a little bit ago. So short answer is yes.
Last question, Michael just says, can you please put the links in Discord? Oh, wait, wrong channel, but still applicable. I think we've gone through all of the questions. So thank you, Sam, appreciate your time.
Thank you, appreciate it, Lee. And let me turn back